All right, so we are solving polynomial equations algebraically. This is another no calculator section, so part 2 is a no calculator, and we are going to solve by factoring. So whenever you're solving by factoring, you want to get all terms to one side so that it's equal to 0. That's so we can use that zero product property, because we know if something is multiplied and equals 0, when you multiply two values together and you get 0, one of them has to be 0. Okay, so when the directions say to solve by factoring, you have to factor it completely. That means if there's a GCF, you have to take that out, and you have to look for those special patterns. So our special patterns were the difference of two squares. Now we've added on the difference of cubes and the sum of cubes. Okay, so all of those are going to be relevant to today's lesson. All right. Do you think we're trying to write that first part down? Okay, so I'm going to give you the first one. It says solve each one by factoring. Really, at this point, you guys wouldn't solve this any other way. Okay, so I want you to go through your steps. Okay, so I want you to start that. If you want to just ignore the equals 0 for now, this is exactly like what you did yesterday on your worksheet. If you are having trouble with where to start, Noah, can you remind us what the first thing you look for? Yep. Okay, step 1, look for the greatest common factor. So what do they have in common? Look for numbers, look for variables. Okay, and then Rocco, can you tell me what the GCF is for this one? Nice, okay, 4x to the 4th. Once you take that out, okay, you are not going to divide, okay? You are going to factor it. If you divide it out, you will be missing some of your solutions when you have a variable here, okay? And so we need to put that on the outside. So once you do that, you're going to divide. Okay, so Abian, can you tell me what I get inside when I divide these by 4x to the 4th?
X squared plus x.
Nice. Minus 6. Yeah, that's okay. So negative divided by a positive is going to be a negative. Okay, and then we're going to factor this down. Okay, so we're going to start with x and x. I'm looking for two numbers that multiply to negative 6 but add to 1. Okay, I want you to go ahead and put those in. Okay, and then tell what you get for your factoring. Nice work. X plus 3, x minus 2. Okay, once you have that, you are going to use the zero product property to solve. So you do need to write this step out. Okay, and then if it's a one-step equation, you don't have to write the one step, but the zero product property, I need you to write that step out because this only works with 0. So the first term is the 4x to the 4th. That equals 0. The second term is x plus 3, that equals 0. And then the last factor is x minus 2. So you're multiplying 4x to the 4th times x plus 3 times x minus 2. We know that one of these has to be 0. Okay, so if it's a one-step equation, like here, you just have to subtract 3. I'm fine if you just jump here. That's okay. Same thing with this. You would just add 2. That's fine. All right, but this is going to be multiple steps, and so we need to show our work for that. So your first step is to get the x by itself. We're going to divide by 4. You have x to the 4th equals 0. If you know what to do, I want you to write it down on your paper. I want you to show the step. Okay, and then Hudson, what did you do when you had x to the 4th? How did you undo the 4th power?
I did like a radical.
Yep, you did the 4th root. So if you take the 4th root of both sides, if it was squared, we do the square root, right? If it was x squared, okay, so if it's 4, we do the 4th root. Okay, the 4th root of 0 is what? 0, because 0 times 0 times 0 times 0 is 0. Okay, so really, anytime you take the root of 0, you get 0. What other numbers like that? 1. When you take any root of 1, it's 1. Okay, so it says solve each polynomial by factoring. You can call these are zeros, these are roots, these are x-intercepts, 0, -3, 2. Okay, it doesn't matter to me what order they're in. Okay, but those are going to be your final answers. Okay. All right. Part B, we have x to the 4th plus 25 equals 26x squared. Okay, your first step is moving everything over to one side, and you can choose which side. Okay, this side obviously looks better for this one because you already have 2 terms there. I always try to move things to the side that will keep that highest exponent positive because that's going to be easier to factor. And if it says solve by factoring, you will be able to factor, okay? So I want you to try to factor this with the first step. There's no GCF, so we're going to start our parentheses. Okay, use some of the skills we talked about yesterday. Okay, so James, how did you start your parentheses here? Say it again. Yep, x squared, great. So to get x to the 4th, we're going to do x squared and x squared. Has to multiply to 25, add to -26. Okay, so Will, what did you get for here and here?
X squared minus 25 minus 1.
Great. Now, one thing that we said earlier is if you are solving by factoring, you have to factor completely. Okay, so if you factor completely, that means you have to notice the special patterns, okay? So in this case, you have to use the difference of 2 squares. And again, that is because the directions are asking you to solve by factoring. So when you are factoring this guy, it becomes x plus 5 times x minus 5. Here you have x plus 1 times x minus 1 equals 0. Okay, so then you're using the zero product property. So I know this part can be a little annoying just because, like in this case, our brain works faster than our pencil. Okay, so I am fine if you set these up and then you just write these out here, okay? So you have -5, -1, okay? And if you want to write it as plus or minus 5 and plus or minus 1, okay, you can do that. The reason why I tell you to make sure you do this is because the directions say to factor, and so we need that, but you could still get your correct answers even if you didn't. So if you set x squared minus 25 equal to 0, you could still find your values of x, right? You would just have to remember when you take the square root, what goes in front of your answers? The plus or minus, okay? So it's not that you couldn't get the correct solutions from there, it's that it's telling you to solve by factoring, okay? So I'm going to be looking for this step, okay? So you have to make sure that you factor completely, okay? All right, let's do part C, which is something that we learned yesterday. So we have x cubed minus 2x squared minus 25x equals -50. Your first step is always getting everything on one side. All right, you guys did a nice job with your grouping. So we're adding over the 50. All right, and then Jaden, can you tell me what you took out of that first group for your GCF here? Nice, and then also just tell me what you got inside, that'd be great. Nice. Once you do that, okay, use this to help you decide what to take out here because you have that -25 in front, but you want the x to be positive. So if you take out the negative, this is going to make this x minus 2, okay, and then these should always match, okay. From there, you have two parentheses. One of them is the x minus 2, one of them is the x squared minus 25. Again, we are not getting rid of an x minus 2. We're rewriting it with the distributive property because if I were to do x squared times x minus 2, I would get this. And if I were to do -25 times x minus 2, I would get that. So I'm just rewriting it with the distributive property, okay? I'm not getting rid of anything. Did we notice that there was the difference of two squares? Always look for that, right? If you have a perfect square, see if you can break it down. And then from there, we're just going to set each one equal to 0. X plus 5 equals 0, x minus 5 equals 0, x minus 2 equals 0, and then your zeros will be -5, 5, and 2. Okay, like I said, as long as you have this step showing the zero product property, I'm okay if you write your answers from there for those one-step equations, okay? All right. Now, example 2 just says to solve each polynomial equation. So sometimes you might need a factor, other times you might have to do something else. Okay, so for our first one, we have x to the 4 minus 3x squared minus 10 equals 0. Okay, the first thing we are always going to do is we are going to see if you can factor it. So I don't have a GCF. This isn't a perfect square. That lets me know I'm going right here. Okay, so then I have x squared and x squared. I have to multiply the -10 but add to -3. So I want you to put those values in there. All right, and then Abby, will you tell me what you got for your two values? Good, okay, so they have to be opposite to multiply to a negative. -5 plus 2 is -3. And then I don't have any perfect squares here, so these are not going to factor again. We can set each one equal to 0. Now we're going to get some answers that aren't whole numbers, and that's okay. So when we solve, this is more than a two-step equation, so we're going to show our work. X squared equals -2. All right, and then to undo the x squared, we're taking the square root. See if you can simplify that. And then do the same thing with this, okay? And then we're going to write down some key things to remember. Whenever you're writing your solutions, they need to be exact and in simplest form. We're going to talk about what that means. And then, Bella, can you tell me what you got for this, what you put for this?
I got x equals √5, x equals, I'm clearly off that line.
No, you're not. It's I just said Bella. That's okay though. That's all right. No, okay. So, well, you got the square root of 5, so I'm going to write that down. Okay, and then you said plus or minus, right? Did you guys get the plus or minus in there? Just make sure that you do. That's an easy thing to miss. Okay, and then Bella, how'd this one go? Yeah, good. Okay, so if you have a negative, you have to remember the I. So nice job. Okay, so we have I root 2, and then will you guys double check that you put the plus or minus in front? Whenever you do this, the number of solutions is going to be equal to your degree. Sometimes zeros occur more than once, and we'll talk about that as well. But the number of solutions you have should be equal to the degree. This is something we'll talk about later on. This is called the fundamental theorem of algebra, is that the solutions are equal to the degree of a polynomial. Okay, so here you have 1, 2, 3, 4. Your degree is 4. Okay, so if your degree is 4, you should have that many solutions. Okay, so 1, 2, 3, 4. That can help you remember the plus or minus. All right, so if you have to be in your simplest form, what that means is if there's a fraction, you got to reduce it. So you have to reduce any fractions. You have to simplify radicals. So if there's any perfect square underneath, you got to take that out. Okay, so those are the perfect squares. Maybe we should say perf. Okay, and then if you have a square root in the denominator, we have to rationalize it. Okay, so when the reason why it's called rationalizing is you're taking something that's irrational and you're making it rational. You're making it a rational number. Okay, so as we go through these, this is going to be our checklist. Is our fraction reduced? Our radicals simplified? That's perfect squares, but that's also going to include negatives. So maybe I should put I above it. Okay, if you have a negative, and then rationalize the denominator. All right, and then you guys are going to start part B. So you have 9x to the 4th minus 27x squared plus 20 equals 0. Okay, as you start this, remember you really have like 2 options for this, right? You can either start with 9x squared and x squared, or 3x squared and 3x squared. I find it helpful to list out my options. Okay, so I'm going to just give you a few minutes to do that guessing and checking so you can figure that out. And then you guys can solve from there, okay? All right, how'd it go? Did you find it? Yeah, so I have to add to negative 27. I have to multiply to 20. So we're going to have to do some guessing and checking. Okay, remember that wherever you put in your values, they're going to be multiplied. So we're going to have to do some type of guessing and checking. Okay, a lot of times people start with a 3 and 3 if they have like a smaller number like this. Because if you did like 10 and 2, this one might be close, negative 10, and then 18 is negative 28. Not negative 27 though. And then you wouldn't want to switch because that would be 90. You wouldn't want to do 20 times that. That would be too big, right? And both of your signs have to be what? Both of your signs have to be negative. Okay, so minus and a minus, minus and a minus. Okay, so Did we find that it was 4 and 5? Because here you have negative 12x squared. Here you have negative 15x squared. That's negative 27x squared. Okay, so that's what's going to fit. Okay, so you can factor this. And then we're going to set each one equal to 0. So 3x squared minus 4 equals 0. Okay, or 3x squared minus 5 equals 0. Okay, it's okay if you don't write the or. It's just x can be one or the other at one time. So generally we put that in between. All right, so when we solve, our first step is to add over 4. Then we divide by 3. In order to undo the square, we take the square root. When you take the square root of a fraction, let's also not forget our plus or minus. We're going to do the square root of the numerator over the square root of the denominator. Okay, and then sometimes you have perfect squares and they simplify. Okay, so this becomes 2 over root 3. You don't want to keep the bottom inside a square root, so we're going to rationalize. Do you guys remember how to rationalize? So what you want to do is multiply by something that's going to make this a whole number, right? So in order to do that with a square root, all you have to do is get to a perfect square. The way to do that is to multiply this by what? 3 itself. Because what's root 3 times root 3? Root 9, which is 3. Yes, exactly. Okay, so when you're doing that, it becomes 2 root 3. And then if you want to put over 3, you can. If you want to think of this as, yeah, that's the square root of 9. The square root of 9 is going to be 3. Okay, that is going to be 2 of your values. Okay, so based on that, I want you to try part B. And then I'll come around and check that. If you want to start thinking about part C, you can. If you're done with that one.
What?
You can't leave it like that. So guys, we just talked about you can't have what in the denominator? A square root. So we do need to simplify that, okay? So you have 3x squared equals 5. Divide by 3. We're going to take the square root. Make sure you are showing this step, okay? That's what undoes the power of 2. And then we're always going to split this up. So if there's a perfect square, we can take that out. If there's not, you still can't have that root 3 in the denominator. Okay, you want that to be a rational number. Now, when you multiply roots, we've talked about you can multiply a root by a root, right? That would be the square root of 15 over 3. Okay, and this again had a degree of 4, so you should have 4 zeros. Okay, so 1, 2, 3, 4. Okay, so we did find them all. All right, for part C, what are we working with here? that one thing from yesterday. Okay, so we have a perfect cube. Okay, so anytime you see that x to the third, that should be a sign for you that, oh, this is probably going to be a perfect power here. Okay, and like I said, you don't have to have them memorized. 216 is going to be on our list. I feel like naturally we know 5 to the third. What's 5 to the third? 125. So the next one I would try is 6. So 6 times 6 is 36. 36 times 6 is 216. Okay, so it is 6 to the third power. Okay, so when we're doing our pattern, our A value is X, our B value is 6. We did a lot of practice with this yesterday, so hopefully we do remember. You have the X plus 6. Whatever sign is here stays, and then you square the first term, and then you do the opposite sign here. We do the product. And then when you square something, it's always positive. That's why this one is always plus. So 6 squared is 36. Now remember, this is now equal to 0, so we have to solve. One thing we talked about yesterday is that this is not factorable. Okay, so if it's not factorable, this will never be factorable. That's what we wrote down yesterday. Okay, so if it's not factorable and you have x squared, you can use something that we've learned this year. If it's x to the power 2, what type of equation is it? A quadratic. And what do we have to solve quadratics? Quadratic formula. Okay, so I'm going to write down the quadratic formula for you. The opposite of b plus or minus b squared minus 4ac divided by 2a. And then this guy here is just x plus 6 equals 0. So x equals negative 6 if you want to have that. All right, so this is going to be a value of 1. B is negative 6. C is 36. Yes, you can do this without a calculator. Yes, you can. Okay, so your opposite of b is 6, plus or minus. Just do this part in your head. What's negative 6 squared? 36 minus 4ac divided by 2a. If you have just a minus here and there's no other negative, you are going to be subtracting. When you do 4 times 36, if you want, you could do 4 times 30, which is 120, and then 4 times 6, which is 24. Add them together. Okay, so underneath the radical, I'm doing 36 minus 144, okay, which is the same thing as 144 minus 36, and then I just put a negative on it. Okay, and so sometimes I just set it up like this. Or you can just think, what's 44 minus 36? I add up. So like 4 to get to 40, 4 to get there, 8. Okay, so this is going to be 108. All right, now we get to have some fun. We can factor tree. Okay, so one thing I've would recommend is that you put the I there, just so you don't forget it when you factor tree. Okay, so when you factor tree the 108, I would start by cutting it in half. So 2 and then 54. Okay, I want you to keep going, and then I want you to write out that simplified root. Okay, these are all skills you have. I'll give you some time to activate that knowledge. All right, so half of 54 is 27. 3 doesn't go, or sorry, 2 doesn't go into 27, so then we'll do 3 times 9. 3 times 3. Anytime there's a group of 2, it comes out. So that's because this is the square root of 4. What's the square root of 4? 2. This 3 times 3 is 9. The square root of 9 is 3. That's why those come out. And then the only thing left inside would be this. So you have 6 root 3 or 6i root 3. And then when you divide by 2, you're dividing both of these by 2. Okay, so this is going to be 3 plus or minus. If it's on the outside, you reduce 3i root 3. Okay, so then you have 1, 2 zeros here. This is your third one. Okay, so you have 3 zeros altogether if it's to the third power. Okay, so you can start to see, hey, these concepts we've been doing, they are going to build on each other. Okay, we need to be proficient at the simplifying. Okay, that way we can focus on some of these other things, and then it doesn't become too overwhelming. All right, you guys ready for the grand finale? I heard yes, please. Can't wait. You heard me. To the sixth power, yep. Okay, so think about how you want to split that up if it's to the sixth power. All right, so when we try to factor this, no GCF, 8 is not a perfect square. Okay, so we're going to start by making our parentheses. And when you're trying to multiply to get something to x to the 6, you're going to have to multiply what by what? Yep, x to the third times x to the third. So it has to multiply to a negative, which means you have opposite signs. Okay, so how can I multiply to 8 but add to 7? 8 and 1. So 8 is positive, 1 is negative. We have 2 cube patterns. So, yay. So we have the sum of cubes here. Here we have the difference of cubes. Remember, the power, the highest power is how many solutions we have. So we need 6 solutions here. Okay, so we are going to do the sum of cubes. And I've been showing how you can write out like each one, but really once you get used to this, what to the third power is x cubed? X. What to the third power is 8? What number to the third power is 8? 2. Okay, and then for the difference of cubes in this pattern, your A is x, your B is 1. Okay, so I want you to use your 2 patterns to set those up. So you'll have the sum of cubes, and then here you'll have your difference of 2 cubes, all equal to 0. All right, you guys got this. This is just twice the fun, twice the sum of cubes.
You're a terrible person.
What is going on?
How dare you ask if that is factorable?
Every single question, which means they got everything wrong.
Oh.
All right, when you are doing your pattern, remember, if it is a sum, you start with a plus, you square the first one, okay? This is the opposite, so minus 2x, and you square the last one, okay? A square is always what? If you square something, it's always positive. You want to say it, Charlotte, you can say it. Always positive, okay? And then here, this is minus. So you start with x minus 1, and then you square. And then if you start with a minus, this becomes a plus. 1 times x, you can write 1x or x. 1 times 1 is 1, okay? Can you ever factor these trinomials? No. So anytime you do this, you have to use the quad formula. Quad formula. In this pattern, if the trinomial is not factorable, okay? We do have 2 answers that we can get real quick here. We have x equals -2, and from here, x minus 1 equals 0 means x is going to be 1. Okay, so we already have 2 answers. Now we're going to find 4 more. So when you set this up, you have your A, your B, your C. The opposite of B is 2. B squared is 4 minus 4AC. Four minus 16, you should get -12 underneath. Now we simplify. Okay, if you have a negative, you have to bring out the I. A lot of you are going to know the perfect square in 12 is 4. So if you know it's 4 times 3, you can just rewrite it as 2 root 3. The square root of 4 is 2. 3 has to stay inside. We're dividing each of these by 2. So we get 1 plus or minus I root 3. Okay, and then for this one, you have x equals, your a is 1, your b is 1, your c is 1. So the opposite of b plus or minus b squared, so 1 minus 4ac. Okay, divided by 2a. So negative 1 plus or minus 1 minus 4 is negative 3. Anytime you have an I, you need to write it in a plus bi form. So when you rewrite this as I root 3, the 2 has to be separated. And you can either write your answer like this, or as negative 1/2 plus or minus root 3 over 2, and you can put the I on the side. Okay, or you can keep the I in front. Okay, now we have our 6 answers. 1, 2, 3, 4, because you have plus or minus, 5, 6. No 7.